Hi everyone, welcome back to my YouTube channel. So I'm going to continue again, solving the third problem from this set of Math AA November 2023, paper 1. So here it's a probability question. So we have two events, events A and B, such that the probability of event A is 0.7 and the probability of event B is 0.75. And the intersection of the probability of event A or event B is actually 0.5. Oh, sorry, event A and B, sorry. So this is event A and B is 0.5. So this is the intersection of A and B. So intersection of A and B, right? So, by the way, this is an and sign, it's not a 2. That is, so we want to find the probability of having event A. So we want to find the probability of event A or event B. So we want to find where we can find both A or B. So usually what I do when I have a problem like this is that I draw the universe. It's weird. Yeah, I draw a small universe. So how this is going to look like. And I would have in my small little universe, I would have A. So this is the world of A. So where all of the A are found. Oh my God, I want to make a clean circle. Doesn't really matter. So I want to have A, and then I'm going to have my universe B right on the side. Okay, that's very ugly, but it really doesn't matter at this point. So I'm going to have A and B that are close to one another, right? So with those two events, I know that with those two events happening, I have something here in the middle. Sorry. I have something here in the middle. So I have A and I have B. And in the middle, I have the intersection between A and B. So this is what the P of A intersects B is actually. So this was given as 0.55. And I know that from this question, the whole red section, the whole red universe world, which is like the planet of A, the whole probability of finding A, that means that this whole region here, as well as a little portion here where A is also found, this whole thing actually is 0.7. Similarly, for B, we have this whole region here and a small one here that also belongs to B, and that is given to us as being 0.75. Now the question is, if this is the probability of finding both A and B, right, this middle part, and this is the world of A, and on this side we have the world of B, where can I find where I have both? I can take either one event, anything from world of A or the world of B. So that is pretty interesting to find. So what I can do is, okay, I can just do P, probability of finding A, or the probability of finding B. Simple, right? So that's what you say. But here's a problem. If let's say, for example, I pick something from A here, and then I pick something from A here, I'm double counting the events of A and B. I just don't want I want to find something that is only found in A when I'm saying or something that is only found in B. But this intersection here means that I'm finding both A and B. So that means that I need to get rid of this section where I can either choose from A or B. So that means after I found what is in A and what is in E, the probability of finding both, I need to get rid of the intersection, something that is happening between them, because I just want to find them exclusively. So not finding where they both merge, where they find together. So what I can do is probability of A minus probability of plus probability of B minus the intersection of the two, which would be 0.7 plus 0.75 minus 0.55. So if I do this one, I'll get 1.5 minus, oh, sorry. Um, so 0.7 times 0, so this would be, okay, I'm just gonna do the math here. So this would be 5, 4, 1. So 1.54 minus 0.55. So this would be 0. This would be 14. 14 minus 5. Oof, I can't do math right now. So this would be 9. So the probability of finding A or B would actually be 0.9. That was quite long, but we found our answer to be for A, it would be 0.90. Now, the asking of the second question, hence or otherwise, find the probability of not A and not B. So this is easy, right? Okay, I'm kidding. So right, let's say we know that the general probability when we're given a set is always going to be 1. So that means that inside of our universe, the total we can get is actually 1. So our universe, where both A and B are, whatever we do, this is always going to be 1. The probability of one and the other are going, if I combine them, it's going to be 1. So that means that the general probability would be of me having 1 minus, right, minus what I have in A and what I have in B. But we just found out that the probability of having either one or the other was 0.99, 0.9, sorry. So that means that if the whole thing has to be equal to 1, so that means that I have included A and B, there's a chance that I can be outside of A and B. So here, without touching A or B, so this whole universe outside, this whole galaxy outside of A or B will be my results because I'm not finding A, I'm not finding B. So that means that I can just do 1 minus 0.90, which would be, what would that answer be? 0.1. So that's my answer. Another thing that I want to point out about IB is that when they give you a sequence of questions and they say hence or otherwise find something, it usually means that whatever you did in the previous example or the previous sets, you're going to be using it again and again. For example, we use the answer that we found for A in B. So if you skip A and you say, oh no, I'm just going to be doing B, think about how the question is being phrased, sorry. If the question say hence or otherwise find P of A minus P of A intersect B, so you need to make sure that we're able to find first the P of A or B before we find the other answer. So that was just me, a tip that I learned from IB as I was doing all of those questions. But feel free to just do whatever you want to do. If it works for you, it works for you. But please let me know in the comments if I need to improve anything. I would love to get feedback. Thank you so much.